I've put a link here to the previous video which talks in a bit more detail about what the Gertboard is and how to assemble one. In this video we're going to look at how to connect to this part here, which is the motor controller, and how we can actually drive a physical motor. I ordered this very small little motor just to demonstrate. It's a geared motor, meaning that it can power things a little bit more powerful, but it does move quite a lot slower, and it's the slower speed allows me to demonstrate this a bit better. So this is how I have wired it up. We have here a battery pack that you can turn on and off, which I got from Maplin in the UK, and the small little motor, and I've just screwed it all into a piece of acrylic, and we've connected up to the motor controller. You can see here we have the positive and the negative wire from the motor, and we also have a positive and a negative wire for the battery pack. So it's a geared motor, and it has this sort of this D-shaped cog on the end, which allows you to connect it up to different things if you want to. And that's just a bit more closer view on that. So this is how essentially you connect up the entire rig. You connect your Raspberry Pi up with its ribbon cable, and then you want to make sure that the bottom pin on your Gertboard, you connect to the positive pin on the battery, and the negative goes to the top. The motor actually doesn't matter which way round you plug it in. Obviously, what we're going to show in this video is the motor going in one direction and then spinning back in the other direction. So depending on which way you plug it in will depend on which way it spins. So a close-up of the actual pins we have here. We have the motor positive and obviously the earth or the negative. Then we have motor A and motor B. So obviously this is where we plug in our battery and the two motor connectors. And that's what we have there. Okay, so what does motor A or mot A and mot B mean? Well, if we send a high signal to either of these 2 points, we get a 1, which is a digital high signal, and 0 is a digital low. So if we send 0, 0 low, that's no movement. If we send 0, 1, so just a high signal to B and a low signal to A, then it will spin in one direction. We flip that and it will spin in the opposite direction, and 1, 1, so high, high, and it won't move at all. And that's how we essentially control it, by sending a high signal to one of our GPIO pins, and then that is routed through the board, which I'll show in a moment. So this is how you connect it up. This is the actual diagram that we're working off. So down here you'll need to use your jumper wires, like I used in my previous video, from GPIO 18 and 17, and you connect them here on the Moto A and Moto B pin headers on the Gertboard. And that's just a close-up of that there. Okay, so when we're programming with the Gertboard, you can get the original set of programming that was done in the programming language C, which I have a link to there and was written by Gert van Loo. Or there's some new code that's been written by a guy called Alex Ames from Raspberry TV, and he's written this in Python, and and there's a link to his details there. So he has within that Python code 2 different sets of test suite scripts. The first one is based off of the Wiring Pi Python interpreter, which is written by Gordon Henderson, and the second time is one called rpi.gpio by Ben Croston, and I'll put a link in the description to both of those. And here is a link to the Raspberry TV stuff. I would recommend to go there and have a look at some of the fantastic things you can do with the Gertboard specifically, and also lots of Raspberry Pi stuff. Something you may not have encountered yet is a pre-assembled Gertboard that you can pre-order to buy. The date at the moment is the 20th of December 2012, so if you're watching this a bit later, this should be available. But at the moment, you can pre-order them from Element 14. So if you're not sure about getting a Gertboard because you weren't feeling confident about all the soldering or weren't really into that, you should be able to, hopefully in early 2013, be able to actually order a fully assembled Gertboard here from Element 14's website. So look out for that, and if anyone orders one, I'd love to see feedback on what you think of it. So when picking a motor, I just look for some hobby stuff. So I could just use a standard 9-volt battery, and once you've got that and your Gertboard, you probably want to watch my previous video which explains how to run the test LED program in C, how to download that and get all that working and compile all the C code, which you'll need to know before you look at this. So do that first, and then hopefully you'll be able to follow the next few steps we have. So if you've watched the previous video and you've compiled all the C code, you're going to want to run the command sudo./motor and hit enter. Then what's going to happen is the motor is going to start off at its slowest setting, speed up to its highest, and then slow down. So they're going to stop, reverse, speed up, and then slow down again. What's happening is that you are sending a high-low signal to the A and B motor pins, and then what's also happening is that the speed of the motor is being controlled by applying a pulse width modulated signal to either the A or the B pins. That's a little bit technical for the beginners channel, but if you want more information about that, the best place is to go to the Gertboard user manual that explains this in a lot more detail than I could possibly go over on the video. And for you more techie people out there, that's a great source of information to go and find out. You'll see that the motor here is actually going quite slowly, and that's because it's a geared motor, which allows you to drive slightly more powerful things, but obviously doesn't have the speed. And it was a great way for me to be able to demonstrate what the motor actually does here. So that's basically the motor controller. I'd love to hear anyone's comments and things they have to say about this particular video. Thank you.